Assalamualaikum to all and our lecturer Dr. Haslina binti Jaafar. My name is Muhammad Nazrin bin NASIRRUZAMAN and my partner is Muhammad SYAZWAN bin RUDIN. Today, we will show the fabrication step for the mirror substrate that are used in MEM optical sensor. First, mirror pattern are formed on a silicon on insulator wafer by lithography and dry etch. Polyimide is then spin coated over the formed mirror. The pattern for the mirror opening on the reverse bulk silicon side are formed and then dry etched using a resist mask. The buried oxide or BOX work as an etching stopper. The BOX is removed with hydrofluoric acid. Then, polyimide is spin coated again on the other side of the coated mirror surface. The polyimide protects the mirror against shock during the dicing step. The protective layer of polyimide is then etched off by exposing it to oxygen plasma after the dicing process. Using this dry process to release the mirror in this final stage prevent the so-called in-process stiction of mirror and improve process yield. The flatness of the mirror surface affect the optical characteristic of the switch containing the mirror array. Both sides of the mirror surface are coated with AU to reduce warpage of the mirror surface, and the AU coating on the top surface also ensure good reflectivity. The peak to valley difference is 0.05 micrometer, indicating a very flat mirror surface.
I will continue with application of optical sensor. Application of this optical sensor range from computer to motion detector. For optical sensor to work effectively, they must be the correct type for the application, so that they maintain their sensitivity to the property they measure. Optical sensors are integral parts of many common devices, including computers, copy machine, and light fixtures that turn on automatically in the dark. And some of common applications include alarm system, synchrons for photographic flashes, and systems that can detect the presence of objects. The example of optical sensor is ambient light sensor. Mostly we have seen the sensor on our mobile handset. It will extend the battery life and enable easy to view display that are optimized to the environment. Next application of optical sensor is biomedical. Basically, optical sensor have a robust application in the biomedical field. Some of the example is breath analysis that using tunable laser, optical heart rate monitor, which is the optical heart rate monitor will measure your heart rate using light, a LED shine through the skin, and optical sensor enzymen are the light that are reflected back. Since blood absorb more light, fluctuation in the light level can be translated into your heart rate. This process is called photolithography. The last application is optical sensor-based liquid level indicator. Optical sensor-based liquid level indicator consists of two main parts: an infrared LED coupled with a light transistor and a transparent prism tip in the front. The LED projects an infrared light outward. When the sensor tip is surrounded by air, the light reacts by bouncing back within the tip before returning to the transistor. When the sensor is deep in liquid, the light disperses throughout and less is returned to the transistor. The amount of the reflected light to the transistor affect output level, making point level sensing possible. That's all. Thank you.